So we're now going to be moving on to the next section. That's going to be section 4B. And what we're going to do now is we're going to continue learning about systems of equations. And we've already learned what they are and how we can solve them graphically. And now we're going to learn how we can solve them a few methods algebraically. So without needing to graph, we can figure out which points will satisfy the both equations that we're giving there. And the method we're going to learn in this video is through substitution. So you guys already know how to substitute, and we're going to go through a problem in the beginning of this video just to refresh our memory on substitution, and then we're going to learn how we can solve a system of equations through substitution. All right, so this video is just going to be going over skills-based and not so much explanation about what systems of equations are, because we've already talked about that in full detail and showed you visually with the graphs as well in the last video. All right, so let's go ahead and get started on some example. All right, so I just want to go over one example with you, a substitution, just to refresh our memory in case you guys forget. Now, we've been doing substitution this year. When we were solving or writing equations, we were substituting in values for x and y, we were substituting in values for our slope and our y-intercept, and we were solving for unknowns. It's exactly what we're doing in this section, but this section is just going to be a little bit more detailed because it's not just going to be a number that you're substituting in for, it's going to be an entire expression. And we'll talk about that in a moment, but let's just refresh our memory with substitution. So it says find a value of 2x plus 14 given that x is equal to 5. So since they tell us that x is equal to 5, they're interchangeable, meaning that anywhere I see an x in this problem, I can replace it with a 5 because we know that they are equal, they're identical, so we can replace them with each other, or we can substitute 5 in for x. So if we want to know what the value of 2x plus 14 is given that x is equal to 5, well, instead of saying 2x plus 14, we can go ahead and substitute 5 in for x. So we can now say 2 times 5 plus 14 because we know that 5 is equal to x. So anywhere I see x, I can replace it or substitute it with a 5. So since there's an x here and x is equal to 5, I can say, well, instead of referring to it as x, we can substitute 5 in and actually solve this. Well, we can go ahead and simplify now. Well, 2 times 5 will give me 10. And now we're left with 10 plus 14, and 10 plus 14 is equal to 24. So given that x is equal to 5, I could substitute it in for my x, and from there, I can then figure out, well, what does this expression actually equal? This expression will then simplify to be 24. If you can understand this process of just substituting 5 in for x, well, when we do these next questions, it's the same thing. It's just going to add a few more steps to it because we're going to have to substitute twice. Right? It may look a little bit challenging when we first do it the first time, but as long as if you can understand that when x is equal to 5 or when two things are equal, we can replace them with each other or substitute it in, then this next part is going to be very simple. All right, so now we're going to go through just a couple problems of actually substituting in a system of equations, and then that'll be it for this video. All right, so the first example we're going to go through is one of the easier ones as far as using substitution, just to introduce it, and then we might go over one or two more examples where they get a little bit more challenging, just to show you different ways it may appear. Now, we know that this is a system of equations by two ways. One, the directions tell us flat out, systems of equations. But if I don't write that, you see this little brace here that's written next to both of these? Well, when we see the two braces written like this is actually telling us that we're looking at these two equations together, that they are a system, that the x and y that satisfy this first equation must also satisfy the second equation at the same time. So it's a solution for both of them. All right, so we can identify that through the directions or through this little brace that's written. We know then that they are a system. And something that we talked about this year as well is if we have an equation, and let's just look at this first one here, y is equal to x. When we have this equation, we have two unknowns. And in order for me to solve an equation with it's impossible for me to solve this equation as is with two unknowns. So in order for us to solve an equation that has two unknowns, we need to have another equation with it, like we do here. And our goal then is to combine these two equations into just one equation with one unknown. All right, so that's what we're trying to do here. We're trying to take these two equations that we have, and we're trying to then see, well, can we combine these to give us just one equation with one unknown so we can solve for it? All right, and the first method we're going to learn, or I guess the second one now, is going to be through substitution. So we look at this very first one. It says y is equal to x. Just like we just talked about in that last question that we did, these are interchangeable. They're equal to each other. So anywhere I see an x, I can replace it with a y. Or anywhere I see a y, I can replace it with an x as well. So once we see that two things are equal, We then look at the other equation that we have, and we're going to substitute in for the variable. So y is equal to x. So that means everywhere I see a y, I'm going to replace it with an x. So instead of this saying 2x minus 5y is equal to 9, I'm going to substitute x in for y. And now I get 2x minus 5x is equal to 9. So you see, through substitution, I'm combining my two equations to get just one. And within this one equation, I now only have one variable. So that tells me, or one unknown. So that tells me that now I can solve this blue equation that I wrote, 2x minus 5x is equal to 9, but after or because we substituted x in for y since they were equal to each other. So now I can just go ahead and solve this like a regular equation that we've learned before. 2x minus 5x, when we need to simplify it, it gives me minus 3x is then equal to positive 9. Well, it's being multiplied, so I'll divide each side by negative 3, and x is then equal to negative 3. So now I know my ordered pair, x is equal to negative 3. Now the last thing I need to do now is solve for y. And now in this equation, it tells us that x and y are actually equal to each other. So I'm now going to substitute this negative 3 here in for my x in this equation. So now we get that y is also equal to negative 3. And now it gives me a final answer that our ordered pair, or our coordinates that satisfy both of these at the same time, are negative 3, negative 3. And we can go ahead and plug that into our equations and make sure that they both hold true to check our work. All right, so in this case, we're substituting, and we're going to end up substituting multiple times. The first time that we substitute is to now combine these two equations that we have into one equation with just one variable. And then after we solve for that variable, we're then going to plug it back in to one of our original equations to then solve for the other variable. So we're actually going to be doing a dual substitution here if we want to think about it like that. All right, we're going to go now through another problem where it's not this flat out, or where it's going to be a little bit harder, where it's not just y is equal to x. Y is going to be equal to a little bit more than that. All right, so let's go through another example. All right, so now let's go through another example. In this example, example 3, still tells us in the directions it's a system of equations, and I also tell you it's a system with this brace here. So we know we're looking for just an x and y that satisfy both of these at the same time. And in both of our equations, we see that we have two variables, so we can't just solve any of our equations as is because we have two unknowns. So we need to go ahead and use substitution to simplify. And we see here that it tells us that y is equal to 2x minus 4. So now it's a little bit different than the one that we just did because now y is equal to an expression. It's equal not only to this x, but it also has that minus 4 there as well. But just like we learned before, we can substitute anywhere in the other, and the key thing is we have to go to the other problem or the other equation that's given to us. Anywhere I see a y, I know that y is equal to 2x minus 4, so I can substitute this 2x minus 4 in for my y. All right, so now we're going to go ahead and substitute that. So we have 7x minus 2 times y is equal to 5. Well, instead of it saying y, I'm now going to say that 7x minus 2 times 2x minus 4 is equal to 5. So we see that the 2x minus 4 is equal to y. So I simply just substitute it in for the y in the problem that I have. And it's very important that you put it in parentheses because we need to make sure that we're distributing this negative 2 to everything. All right, so now we're going to solve this like a regular equation. We now only have one unknown in this problem, and it's something that we had done before. We have done problems that look like this plenty of times throughout the year. So we're now going to distribute this negative 2 in to start simplifying. So now I have 7x minus 4x because negative 2 times 2x, and then negative 2 times negative 4 is plus 8 is equal to 5. Now I'm going to go ahead and keep simplifying. 7x minus 4x is 3x, so 3x plus 8 is equal to 5. And now just like a regular multi-step equation that we have solved plenty of already this year. We'll first subtract the 8, so now we get 3x is equal to negative 3, and then we're going to divide each side by 3, and we get x is equal to negative 1. So we now started to solve for our ordered pair of negative 1, and now we just need to figure out what y is. So now, the way that we do that is we just figured out that x is equal to negative 1. Well, we know that y is equal to 2x minus 4. So instead of it saying y is equal to 2x minus 4, let me just draw this line down here. Instead of it saying y is equal to 2x minus 4, where I see x, I can now substitute it with negative 1 since we know that that is what x is equal to. Just like we did when we're writing equations, we're substituting in. So now we have y is equal to 2 times -1 minus 4. And now we just go ahead and solve this. 2 times -1 is -2. -2 minus 4 gives me -6. So that means our ordered pair, or our solution, is -1, -6. And you will need to write your answer as an ordered pair. All right, make sure this is how you're writing your answer, and you're not saying x is equal to -1 or y is equal to -6. You write it as an ordered pair because it's telling us that we need to use both of them at the same time, and both of those together are our solution. All right, so our final answer is here, written as an ordered pair of -1, -6. And if you can imagine this, if we were to graph both of these on our graph, that is where the two lines will overlap. That is the only point that will satisfy both equations at the same time. All right, there's one more example I'm going to go through just to show you another way it may appear, and just adds this one more little step or wrinkle. But if you can do this, you can do any of the substitution problems that we're going to do going forward. All right, so here's the last example that we're going to go through. So in this system of equations, it tells us x plus 4y is equal to 14, and 3x plus 7y is equal to 22. Now, none of these have been written where a variable is equal to something, like it was in the other ones. We knew x was equal to y, and we knew that y was equal to 2x minus 4, or whatever that was. So we had something already set equal to. None of these they do. So sometimes we might need to rearrange our equations to then set equal to a variable. If you have a variable that has a coefficient of 1, which in this case it does, then that's the easiest for us to go ahead and solve for, because we don't need to worry about dividing anything at the end. So I'm going to first rearrange this x plus 4y is equal to 14 into a problem, or into a rearrange it so that it just shows me x is equal to. So in order to solve for x, we just need to remove or move the 4y to the other side, and we can do that through subtraction. So now we have x is equal to -4y plus 14. These are both the same equation, just written in different ways. But now by writing it like this, we now said that x is equal to something. And now we can use substitution, because we know everywhere I see an x in that other problem, I can replace it with this -4y plus 14. So I wanted to show you that, one, we don't always have to substitute for y, and two, sometimes we will need to manipulate or rearrange our equations, which is why I was really pushing for you to understand and learn that earlier in the year as well. All right, so now we take the other equation, 3x plus 7y is equal to 22. And now instead of it saying 3x, I'm going to write 3 times -4y plus 14, because we know that x here is equal to -4y plus 14, so I can replace it or substitute it. And now I still have my plus 7y is equal to 22. So by doing this, I now have an equation that only has one variable, which allows for me to solve. So now I'm going to distribute in. 3 times -4 is -12y, and 3 times 14 is going to give me plus 42. And now we still have the plus 7y is equal to 22. I'm going to go ahead and simplify. -12y plus 7y is going to give me -5y. Plus 42 is equal to 22. And now we're going to use what we've learned before to start isolating our variable. So we'll subtract 42 from both sides. And now I get -5y is equal to -20. And our last step will be to divide by that coefficient of -5. So y is equal to 4. So now we know that we have an ordered pair of x, 4. And now we just need to solve for x. So to do that, we can plug it into any of the equations we have here. But I'm always going to suggest that you plug it into the equation that we have that is set equal to the variable. So I'm just going to go ahead and plug it into this x is equal to, because it's already set up for me for x is equal to. I can plug it into any of them though. If you want to, because maybe you're afraid that you made a mistake somewhere else, you can always plug it into one of these original equations, and it can maybe help you catch your mistake. But unless you're graphing it to check your work, or unless you're actually substituting it in to check your work, you won't see that mistake anyway. All right, so once I know that y is equal to 4, I'm now going to say, well, x was equal to -4y plus 14. Well, now I know that y is equal to 4, so everywhere I see a y, I can substitute it in with 4. So now I'm going to say, well, x is equal to -4 times 4 plus 14. It should be a 14. So then x is equal to -16 plus 14. So that means x is equal to -2. So our final answer in our ordered pair is when x is -2, y is 4, and that would be the ordered pair that satisfies both of these equations at the same time. All right, that is it for this video.